To wrap up this section, we're going to revisit that R sub n, that remainder of order n term. And this is the remainder estimation theorem. It says if there is a positive constant m such that the absolute value of the n plus first derivative is less than or equal to that value m for all t between x and a, then the remainder term in Taylor's theorem is going to satisfy this inequality. The absolute value of that remainder term will be less than or equal to m times the absolute value of x minus a to the n plus first power over n plus 1 factorial. So we're going to use this remainder estimation theorem to estimate an error. It says estimate the error if the Taylor polynomial of order 3 is used to estimate the value of sine x when x is equal to 0.1. So it says the Taylor polynomial of order 3 is x minus x cubed over 6. So I want to use this remainder estimation theorem. And I first need to find this value m. Now, since my function, my original function is just sine of x, when we take the derivatives, it's going to go sine of x, cosine of x, negative sine of x, negative cosine of x, sine of x. They're going to repeat a pattern, but it's always going to go back and forth between sine or cosine. It might be positive or negative, but it's always going to go flip back and forth between those two functions. We then know that if we take the absolute value of the n plus first derivative, okay, since we're taking the absolute value, it's either going to be the sine function or the cosine function. Well, it's always going to be less than or equal to 1. And that holds true for all x. So now we have our value of m. M here is going to be 1. So we can use this remainder estimation theorem. Now, it says that x is 0.1 and a here is 0 because it's the Taylor polynomial of just x. If a was something other than 0, you'd have the Taylor polynomial where you'd have x minus some number. Okay, so we know that a is 0 and it tells us that x is 0.1. So this remainder is our error. So in this case, we know that the absolute value of our error is less than or equal to m, which we just said is 1, times the absolute value of x minus a. So in this case, it's 0.1 minus 0. So it's going to be 0.1. And I can drop the absolute value because it's positive, to the n plus first power. So n here is 3. So the n plus first power is 4. And that's over n plus 1, which again is going to be 4 factorial. Well, the 1 isn't going to affect anything. I can rewrite this 1/10 to the 4th power. I can write this as 1 over 10 to the 4th times 4 factorial. So 10 to the 4th would be 10,000. 4 factorial is 4 times 3 times 2 times 1, so it's 24. So you've got 1 over 24,000 here. And that's, if you round it, it's going to be just slightly less than 4.2 times 10 to the negative 6. So our error is less than 4.2 times 10 to the negative 6.